Good evening, one and all. We welcome you all to the International Seminar on Space Exploration, Space Missions, Moon Day, Environment, Health, Well-being and Sustainable Development 2023. Commemorating Azadi Ka Amrit Mahotsav, nation celebrating 75 years of independence, India's G20 presidency, UN Sustainable Development Goals 2015 to 2030, as part of awareness and campaigns in collaboration with Sri Holistic Health Foundation India and Sri Research Institute Center for Art, Sciences and Wellbeing and others. So before we start today's proceedings, let's take the blessings of Almighty.
कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः.
With the blessings of Almighty, we shall continue with today's sessions. Today, we are commemorating Space Exploration Day and also Moon Day, and we are also commemorating International Chess Day and World Jump Day today. So we'll be commemorating, and we have a speaker, but due to some technical problem, he is not able to connect. He is into space research, but we will wait because it's heavily raining here since almost 4 or 5 days, and a lot of connectivity issues as well. So we'll see if the speaker joins by the end of the session. It's fine. Otherwise, we'll continue our sessions. And as this was a very short notice, just today morning only, we thought almost in the afternoon, not even morning, we thought we'll commemorate this day. Anyway, we are doing daily commemorations. We thought we'll put in the form of seminar. So due to short notice, we could not inform many. Apart from very few, we request everyone to share among your circles so that many can be benefited. So there is no registration form for this initially. So later on, after we have already shared in the chat box and we have circulated registration form with you, which is also the feedback form and certificate form. So all together, you will be filling it up after this seminar. Once the seminar concludes, we will open the form for responses. You can fill up the form only for those who are attending and presenting. In the meanwhile, we'll be taking feedback in Zoom session also. The same form link is available on the website also. No need to worry if you miss out the links. You can visit the website and fill up the feedback form within 24 hours. So that form includes both registration as well as feedback. So you are requested to fill the feedback form and also registration form after the seminar. So let's move on to today's commemorations. Today, we are celebrating International Moon Day. It is commemorated by United Nations and UNESCO. The General Assembly declared International Moon Day a United Nations designated international day to be observed annually on 20th July in its resolution 76/76 on international cooperation in the peaceful uses of outer space in 2021. So International Moon Day marks the anniversary of first landing by humans on the moon as part of Apollo 11 lunar mission. The celebrations will also consider the achievements of all states, nations in the exploration of moon and raise public awareness of sustainable moon exploration and utilization. We have seen recently India has launched Chandrayaan-3, and it is the first country, first nation to launch a mission to moon, which is going to be landed on the south of moon, which is the first country to land on the southern pole of the moon. And India stands as one of the few countries, in fact, only one among those countries which have been successful in launching moon missions with a very less budget than compared to other countries. You know, even we have launched, ISRO has made our nation proud that the entire lunar missions that costed less than a Bollywood movie or a Tollywood movie. So you can imagine, with less than a budget of a movie, space missions are launched and successfully accomplished. That is the greatest thing that India has shown to the world. With such a low budget also, nations can excel in the space. And today, India remains one of the leaders in the space and space technologies and also space missions. So for thousands of years, human civilizations have looked up to the sky, pondering the origin and mysteries of moon, our only natural satellite. Ground-based observations enabled by the invention of the first telescopes opened a new chapter in our understanding of our celestial companion. With the birth of space activities, the moon became the ultimate destination of countless missions, including crewed flights that brought the first human footprints to another place in the universe. As moon exploration efforts continue taking shape with ambitious plans, this global celebration will not only serve as a reminder of success in the past, but also an annual testimony to the future endeavors. From the very beginning of the space age, the United Nations recognized that outer space added a few dimensions to the humanity's existence. The United Nations family strives continuously to utilize the unique benefits of outer space for the betterment of all humankind. So recognizing the common interest of the humankind in outer space and seeking to answer questions on how outer space can help benefit the people of Earth. The General Assembly adopted its first resolution related to outer space, Resolution 134H, 13th, entitled Question of the Peaceful Use of the Outer Space. On 10th October 1969, the Magna Carta of Space, also known as the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including Moon and other celestial bodies, entered into force. Today, the United Nations Office for Outer Space Affairs, in short known as UNOSA, is the United Nations office responsible for promoting international cooperation in the peaceful use of outer space. So UNOSA serves as the secretariat for the General Assembly's only committee dealing exclusively with international cooperation in the peaceful uses of outer space. The United Nations Committee on the Peaceful Uses of the Outer Space, COPUS. So UNOSA is also responsible for implementing the Secretary General's responsibilities under international space law and maintaining the United Nations Register of Objects launching into outer space. So the United Nations Office for Outer Space Affairs, in short known as UNOOSA, UNOSA, works to promote international cooperation in the peaceful use and exploration of space and in utilization of space science and technology for sustainable economic and social development. The office assists any United Nations member states to establish legal and regulatory frameworks to govern space activities and strengthen the capacity of developing countries to use space technology and applications for the development by helping to integrate space capabilities into national development programs. The United Nations Office for Outer Space Affairs, in cooperation with the China Manned Space Agency, launched the program which capitalizes on the technological and innovative skills of the government of China to benefit member states of the United Nations, in particular developing countries, thereby contributing to the 17 Sustainable Development Goals through increasing access to space. So there are various treaties and principles related to space. The Committee on the Peaceful Uses of Outer Space is the forum for the development of international space law. The committee has concluded 5 international treaties and 5 sets of principles on space-related activities. These 5 treaties deal with issues such as non-appropriation of outer space by any one of the country, arms control, the freedom of exploration, liability for damage caused by space objects, the safety and rescue of spacecraft and astronauts, the prevention of harmful interference with space activities and the environment, the notification and registration of space activities, science investigation and scientific investigation and the exploitation of natural resources in outer space and the settlement of disputes. Each of these treaties stresses the notion that the outer space, the activities carried out in the outer space, and whatever benefits might be accrued from outer space should be devoted to enhancing the well-being of all countries and humankind, with an emphasis on promoting international cooperation. So, as part of this, the treaties commonly referred to as 5 United Nations treaties on outer spaces are the Outer Space Treaty, Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies, adopted by the General Assembly in its resolution 2222 of 21, opened for signature on 27 January 1967, entered into the force on 10th October 1967. The rescue agreement on the rescue of astronauts, the return of the astronauts, and the return of objects launched into outer space, which is adopted by the General Assembly in its resolution 2345/22, opened for the signature on 22nd April 1968, entered into force on 3rd December 1968. And the third treaty, the Liability Convention, Convention on International Liability for Damage Caused by Space Objects, adopted by the General Assembly in its resolution 2777/26, opened for signature on 29th March 1972, entered into force on 1st September 1972. And the fourth treaty, the Registration Convention, Convention on Registration of Objects Launched into the Outer Space, adopted by the General Assembly in its resolution 3235. And 29, opened for signature on 14th January 1975, entered into force on 15th September 1976. And finally, the fifth treaty, the Moon Agreement, agreement governing the activities of states of the moon and other celestial bodies, adopted by the General Assembly in its resolution 34/68, opened for signature on 18th December 1979, entered into force on 11th July 1984. So there are 5 declarations and legal principles are the Declaration of Legal Principles governing the activities of states in the exploration and uses of outer space, and the Broadcasting Principles, the principles governing the use by states of artificial earth satellites for international direct television broadcasting, the Remote Sensing Principles, the principles relating to remote sensing of the earth from outer space, the Nuclear Power Sources Principles, the principles relevant to the use of nuclear power sources in the outer space, the Benefits Declaration, the Declaration on the International Cooperation in the exploration and the use of outer space for the benefit and in the interest of all states, taking into particular account the needs of developing countries. At the end of the year 2022, the Office for Outer Space Affairs launched a new database called Accessing Space Treaty Resources Online, in short known as ASTRO. The platform serves as a database of international space instruments, including 5 United Nations treaties on outer space and their ratification status and principles adopted by the General Assembly. So these are the 5 space laws, treaties, and also principles. And United Nations Register of Objects Launched into the Outer Space is a register maintained by United Nations, by United Nations Office for Outer Space Affairs. Since 1962, the United Nations has maintained a register of objects launched into outer space, originally established as a mechanism to aid United Nations Committee on the Peaceful Uses of Outer Space in the discussion on the political, legal, and technical issues concerning outer space. The evolution of the international space law resulted in space objects registration becoming a means of identifying which states bear international responsibility and liability for space objects. Following multi-year discussion among states, the Convention on Registration of Objects Launched into Outer Space entered into force in 1976. States and international intergovernmental organizations that agreed to abide by The convention are required to establish their own national registries and provide information on their space objects to the Secretary General for the inclusion in the United Nations Register. Responsibility for maintenance of the register was delegated by the General Secretary General to the United Nations Office for Outer Space Affairs. As required under the treaty, UNOSA publicly disseminates the information provided as the United Nations documents, which are available through its website and through the United Nations official document system. To date, approximately 87% of all satellites, probes, landers, crewed spacecraft, and space station flight elements launched into Earth orbit or beyond have been registered with the Secretary General. Space technology and its applications played an important role in supporting the 17 Sustainable Development Goals established under 2030 Agenda for Sustainable Development. Space for SDGs highlights how outer space can be used for monitoring and achieving sustainable development goals. Despite the growing economy, Despite the growing global economy and the technology's progress observed in the past decades, there are still many societal challenges that need to be overcome to enhance human development. The United Nations, involving more than 190 member states, has developed the 2030 Agenda for Sustainable Development in order to address these changes in the form of 17 Sustainable Development Goals with 169 associated specific targets. The importance of the role of Earth observation and geolocation provided by the GNSS in supporting the achievement of the development goals is recognized by the UN General Assembly, Resolution 70/1, Transforming Our World, the 2030 Agenda for Sustainable Development. However, the potential of the space in supporting the SDGs is much wider. Space-based services and technologies are key in understanding climate change and during the full disaster management cycle. Only 2 examples among countless applications to which space can contribute to. So let's look at each of the goal and how space technologies are used in the sustainable development. Looking at goal number 1, no poverty. Sustainable Development Goal 1 calls for an end to poverty in its all manifestations by 2030. It aims to ensure social protection for the poor and vulnerable, increase access to the basic services, and support people harmed by climate-related extreme events and other economic, social, and environmental shocks and disasters. Space technologies are central, among other things, in forecasting natural disasters and better coordinate subsequent aid provision, optimizing sustainable utilization of natural resources, providing efficient support to vulnerable populations, mapping populated areas and their access to basic services. Overall, space technologies can contribute to the prevention of falling below the poverty line and help target specific support to those in need. About 1 in 5 persons in developing regions lives on less than $1.25 per day. Globally, 18,000 children still die each day from poverty-related causes. Precision agriculture, integrating GNSS and EO data, can achieve yield increases over 10% and reduce other fuel, fertilizer, and pesticide inputs by up to 20%. This contributes to elevating poverty by ensuring adequate and continued access to food and natural resources while reducing adverse economical impacts. Economic losses from internationally reported disasters, principally large-scale disasters, have grown steadily since 1990, reaching an estimated annual average of $200 billion in 2013. Space-based technologies such as remote sensing for Earth observation, satellite-based telecommunications, and global navigation satellite systems contribute to disaster risk management and emergency response efforts. Since the establishment in 2006 of UN SPIDER, UNOSA has supported countries in their use of all types of space-based information in all phases of disaster management cycle, including prevention, preparedness, early warning, response, and reconstruction. In particular, from 2010 to 2018, the office worked with the government of the Dominican Republic on the use of space-based solutions for disaster risk reduction, strengthening its institutions and providing technical advice on incorporating the use of space-based information into its activities. The Dominican Republic regularly faces extreme weather events, including hurricanes and tropical storms, which have caused floods, landslides, and storm surges that result in the loss of life, the displacement of affected communities, and the destruction of property. Since 2016, the country has faced three devastating hurricanes: Matthew in 2016 and Irma and Maria in 2017. Sustainable Development Goal 2 aims to end hunger and all forms of malnutrition. It also commits to the universal access to safe, nutritious, and sufficient food throughout the year. This requires sustainable food production systems and resilient agriculture practices, equal access to the land and technology and markets, and international cooperation on investments in infrastructure and technology to boost agriculture productivity. Space technologies are key to optimizing crop productivity through informed management process and increased efficiency in the use of existing resources, including land, seeds, fertilizers, plant protection agents, and water, improving livestock management through enhanced monitoring and identification of suitable grazing. The space-based technologies offers tools to help in a wide spectrum of agriculture activities, ranging from monitoring of crops, livestock, and forestry to fisheries and agriculture, aquaculture. They are essential for supporting farmers, fisherfolk, foresters, and policymakers in the decision-making process by enabling timely and effective response to adverse weather conditions, droughts, floods, desertification, and land degradation, vegetation fires, and disaster triggered by natural phenomena. Among such technologies, remote sensing satellites provide key data for monitoring soil, snow, cover, drought, and crop development. Furthermore, rainfall assessments from satellites help farmers plan the timing and amount of irrigation necessary for their crops. The Space for Agricultural and Food Security Report 2016, produced by the UN Interagency Meeting on Outer Space Activities, UN Space, led by UNOSA, features how space-based technologies are used for supporting decision-making in the fields of agriculture and food security and for overcoming challenges posed to future prosperity, security, and well-being of the humankind. In 2017, heavy rainfall caused deadly flooding and mudslides in and around the capital of Sierra Leone, Freetown. The cascading after effects of the rainfall peaking with the collapse of a hillside, resulted in hundreds of casualties. In response, UNOSA, with the collaboration of the Food and Agriculture Organization of the United Nations, FAO, requested the provision of satellite imagery of the incident through the activation of the European Commission Copernicus Emergency Mapping Service and initiated the activation of the International Chapter Space and Major Disaster. The maps that were created provided an invaluable tool for local organizations to plan their response, offering access to information like the type of landslide, the exact extent of mud flow, the number of buildings, roads, and infrastructure affected, and the number of people that may have been impacted. Sustainable Development Goal 3 seeks to ensure health and well-being for all at every stage of life. The goal addresses all major health priorities, including reproductive, maternal, and child health, communicable, non-communicable, and environmental diseases, universal health coverage, and access for all to safe, effective, quality, and affordable medicines and vaccines. It also calls for the more research and development, increased health financing, and strengthened capacity of all countries in health, risk reduction, and management. Space technologies are essential in a range of health applications, including, but not limited to, studying disease epidemiology by enabling increased use of spatial analysis to identify the ecological, environmental, and other factors that can contribute to the spread of vector-borne diseases, monitoring disease patterns, and defining areas that require disease control planning, addressing issues related to vision, cognition, and disability assistance, monitoring facts that affect human health and well-being, like air quality and traffic, supporting health promotion and disaster prevention through the use of wearable monitoring devices, enabling remote healthcare. So overall, space technologies can contribute to the prevention of people falling below the poverty line and help target specific support to those in need. Some medical research can only be performed in orbit, aboard from space station where there is only microgravity, the same weightlessness that lets space-suited astronauts move massive objects easily also offers a unique learning opportunity, as in the case of zero gravity effects on astronauts' skeletal system. And loss of bone and muscle mass. For example, due to extreme bone loss, experiments in space offer a unique opportunity to develop a cure for osteoporosis. Microgravity allows unique conditions for growth of protein crystals where there is no gravity or convection to disrupt their growth. The protein expressed in certain muscle fibers of patients with Duchenne muscular dystrophy, which affects 1 in 3,500 boys, has been successfully crystallized in space, revealing a new inhibitor, several hundred times stronger than the prototype inhibitor. A surgical instrument inspired by the Canadian Space Agency's heavy lifting and maneuvering robot arms on the space station is in clinical trials for use in patients with breast cancer. The image-guided autonomous robot works inside an MRI machine to help accurately identify the size and location of the tumor. Globally, about 1,400 infectious diseases afflict the human population. Some of them are the most important causes of death. Some of them are important causes of death in developing countries. Half of the world's population lives in affected areas. So UNOSA, through advisory and financial assistance, helps space agencies and research program on the space applications provide practical assistance to the member states to the use satellite remote sensing, global positioning, GIS, and satellite communications to integrate ecological, environmental, and habitation data into models for disease, surveillance and control activities, and develop collaboration with relevant entities such as World Health Organization. Furthermore, UNOSA organizes international conferences, workshops, and expert meetings on the use of space technologies for global health, addressing issues like telehealth, infection, surveillance, and space cooperation for global health, and facilitates discussion through its relevant working group on health plans. Sustainable Development Goal 4 aims at ensuring exclusive as well as inclusive and equitable quality education and promote lifelong learning opportunities for all. This goal ensures that all girls and boys complete free primary and secondary schooling by 2030. It also aims to produce equal access to affordable vocational training, to eliminate gender and wealth disparities, and achieve universal access to a quality higher education. Estimates show that among those 59 million children, 1 in 5 of them have dropped out, and recent trends suggest that 2 in 5 out of school children will never set foot in its classroom. So the Sustainable Development Goals clearly recognize that the gap must be closed, even as the international community more explicitly address the challenges of quality and equity in education. So space technologies can provide, among others, high-speed internet connectivity and tailored online educational content delivered via satellite, electronic attendance monitoring and provisioning of incentives for parents to reduce dropout rates, remote learning, e-learning, and lifelong learning opportunities for the remote and isolated communities. So there were various studies on nanosatellite technologies, recognizing its unique role in supporting capacity building efforts and being a catalyst for a broad engagement in space activities in developing countries. UNOSA has launched a series of initiatives directly addressing SDG 4, like Space for Women, Space for Youth. Furthermore, UNOSA offers, in cooperation and with its partners, the support of fellowship programs. The capacity building effort in educational institutes throughout the world have become a cornerstone of the offices to promote the benefits of space activities. The fellowships cover topics on nanosatellite technologies and microgravity and are designed to act as a motivation for younger generation to pursue a career in a space-related field. UNOSA offers the following opportunities, like UN Japan Long-Term Fellowship Program on Nanosatellite Technologies, Fellowship Program for the Drop Tower Experiment Series, in short known as DROPTIS, in Bremen, Germany, and Unispace Nano Satellite Assembly and Training by ISRO, Unnati, Bangalore, India. As an access to education is pivotal in improving quality of life, and also help equip locals with the necessary tools to develop, innovate solutions to the core issues tackled by SDGs. UNOSA is supporting through its program on space applications, 6 regional centers for space and science technology education in order to facilitate the development of local capacities in the field of space technologies located in Africa. Located in Africa, Asia and the Pacific, Latin America and the Caribbean and the Western Asia, and the 6 establishments are targeting mainly developing countries through their courses to ensure a common standard teaching of the center's education curricula have been developed in major fields of space applications like satellite meteorology and global climate, satellite communications, space and atmospheric science, remote sensing and geographic information systems, global navigation satellite systems. In Asia, we have it in India and China and Jordan. In Africa, we have in Moscow, Nigeria, in South America, in Brazil, in Central America, in Mexico. These are the 6 centers. Which are regional centers for space science and technology education affiliated to the United Nations. So coming to SDG goal number 5, seeks to achieve gender equality and empower all women and girls. Gender equality and women's empowerment have advanced in recent decades. Women's and girls' access to education has improved. The rate of child marriage has fallen and progress has been made in the area of sexual and reproductive health and reproductive rights, including fewer maternal deaths. Nevertheless, gender equality remains a persistent challenge for countries worldwide, and the lack of equity is a major obstacle to sustainable development. As gender and wealth disparities persist and obstruct universal access to a quality higher education. So space technologies can support women's empowerment through access of quality education, even in remote and isolated communities, support for female entrepreneurship through access to training, soft infrastructure, information training, information and safety in the work environment, career development opportunities, often with STEM. So the growth of space sector encourages women to pursue STEM education and develop the required skills to access the meaningful employment and leadership opportunities it provides. Also, while other SDGs address poverty, health, and education, these challenges are also intertwined with gender equality. The space sector plays innovative solutions with methodologies which can be integrated into gender perspective to solve the specific developmental difficulties that women experience. UNOSA's Space for Women project helps empower women in space and STEM by creating an online mentoring platform for younger women in STEM to network with experienced space for women champions. It links women to positive female role models who can advise and guide them to opportunities in the field. Throughout Through Space for Women, UNOSA also provides policy-relevant advice, knowledge management, and evidence-based awareness, raising research and data to institutions and governments to implement programs supporting space for women and women for space. Achieving gender equality and female empowerment by breaking down gender barriers is a key factor to strive for peace, defend rights, promote the well-being of all, and encourage economic growth. The International Gender Champions Network provides the platform for a stronger action to promote gender equality, consisting of a broad range of factors. The International Gender Champions signed the panel parity pledge not to sit on single-sex panels and take on 2 additional individual commitments to support gender equality. Simonetta Di Pippo, Director of the United Nations Office for Outer Space Affairs, is one of the international gender champions. Her 2 commitments to achieve gender equality at UNOSA are advise and encourage delegations to committees to launch or support as appropriate measures, decisions, and initiatives promoting gender equality across the entire spectrum of their activities in the field of peaceful exploration and uses of outer space. Make sure that the formal statements delivered on behalf of UNOSA contain a vocal emphasis from a gender perspective as appropriate. Develop a fully fledged Space for Women project to facilitate the strengthening of the awareness of the capacity and skills of individuals and institutions related to the importance of promoting gender equality and in the space sector and its fundamental educational fields by 2019, with the following cornerstones as facilitating access to the space sector education as well as the space sector itself, providing policy-relevant advice and awareness raising to institutions and governments on space for women and women for space, facilitating capacity building training of individuals on access to use of space technology, promote mentoring platform on space for women champions. Sustainable Development Goal 6, Clean Water, pursues to ensure availability and sustainable management of water and sanitation for all. Clean, accessible water for all is an essential part of the world we want to live in. There is sufficient fresh water on the planet to achieve this. However, every year, millions of people, most of them children, die from diseases associated with inadequate water supply, sanitation, and hygiene. Clean water, basic toilets, and good hygiene practices are essential for the survival and development of children. Today, there are around 2.4 billion people who do not use improved sanitation and 663 million who do not have access to improved water sources. Every day, over 800 children die from preventable diseases caused by poor water and a lack of sanitation and hygiene. Space technologies enable, among others, water quality monitoring, meteorological forecasting, access to infrastructural support, and technical know-how. SDG 6 focus on clean, accessible water for all. The goal aims to address water scarcity, poor water, and inadequate sanitation globally. It promotes increased investments in water management and sanitation and international cooperation and capacity building in this respect. Water conservation and management are among the most critical issues facing humankind. Space technology can help analyze global water cycles, map water courses, and monitor and mitigate effects of floods and droughts. In 2016, UNOSA and the Prince Sultan bin Abdul Aziz International Prize for Water, in short known as PSIPW, signed a memorandum of understanding to collaborate on promoting their common goals, particularly the use of space-based technology for the increased access to water. Through this collaboration, UNOSA has developed and launched a portal on the space for water management referred to as Space Water Portal. So the Space Water Portal is a multi-stakeholder platform for interdisciplinary knowledge exchange on space technologies and water-related topics. It serves stakeholders on both the space technologies sector and the water sector and aims of strengthening the links between the various actors and communities. Its scope is to foster knowledge exchange and to bring the benefits of space to humankind. While one of its key focus areas of the portal is capacity building. The portal brings together organizations active in the field to share information on projects, initiatives, satellite missions, and software, while enabling access to community portals, capacity building, and training materials, conferences, workshops, data, as well as news and publication in the sector, providing important services, particularly to actors from developing countries. The first cooperation agreement between UNOSA and the Prince Sultan bin Abdulaziz International Prize for Water was established in 2007. This collaboration enabled both parties to organize, establish diverse capacity building events, that workshops to share best practices and success stories on the use of space technologies for better water management. The wide geographical distribution of the event allows for a diverse audience to benefit from knowledge and information exchange to develop local capacities. Among these events, particularly notable was the first United Nations Saudi Arabia UNESCO International Conference on the use of space technology for water management, co-organized by UNOSA, UNESCO, PSIP, and King Abdulaziz Center for Science and Technology, was held in Riyadh in April 2008. Furthermore, the United Nations Argentina International Conference on the use of space technology for water management was jointly organized by UNOSA as part of the activities of the United Nations Program on Space Applications for 2011. The government of Argentina, the European Space Agency, and the General Secretariat of PSIPW. The event was hosted by Commission Nacional de Actividades Espaciales on behalf of Government of Argentina. In 2014, UNOSA, in cooperation with the Government of Morocco, ESA, the General Secretariat of PSIPW, organized the third international conference on the use of space technology for water management. The conference was hosted by the Royal Center for Remote Sensing, CRTS, on behalf of Government of Morocco. In 2018, UNOSA, the Government of Pakistan, and PSIP jointly organized the fourth international conference on the use of space technology for water management in collaboration with Inter-Islamic Network on Space Sciences and Technology to promote use of space technology in water management for the developing countries. Lastly, in 2022, UNOSA, the Government of Ghana, and PSIPW organized the fifth international conference on the use of space technology for water resource management, supported by the European Space Agency and the Inter-Islamic Network on Space Sciences and Technology, in short known as ISNet, to promote the use of space technology in water management for benefit of the developing countries. Sustainable Development Goal 7 aims at ensuring access to affordable, reliable, sustainable, and modern energy for all. Energy is central to nearly every major challenge and opportunity the world faces today. Sustainable energy is an opportunity to transform lives, economies, and the planet. Still, 1 of the 5 people lack access to electricity, and as demand continues to rise, there needs to be a substantial increase in the production of renewable energy across the world. The proportion of the world's population with access to clean fuels and technologies for cooking increased from 51% in 2000 to 58% in 2014, although there has been limited progress since 2010. Space technologies are central in critical infrastructure monitoring, particularly with regard to the energy networks, power grid synchronization, seismic surveying, identification of optimal sites for production of renewable energy, solar and wind energy production, forecasting to estimate the amount of energy that needed for other sources. Every hour, the sun beams onto Earth more than enough energy to satisfy global energy needs for an entire year. Spacecrafts in the inner solar system usually rely on the use of photovoltaic energy, and different space agencies are financing research to increase the efficiency of the solar cells. The first solar-powered satellite, named Vanguard 1, was launched in 1958. Satellites can be used to collect solar energy so that it can be distributed for use all over the Earth. Solar-powered satellites, otherwise known as power stats, orbit the Earth and are designated to capture solar energy and transmit that energy to receiving stations that are situated thousands of miles from each other on the surface of the Earth. These satellites are made up of a number of modules outfitted with lightweight photovoltaic solar panels. Space is contributing to the management of smart grids, as their development is not possible without global navigation satellite systems, which provide the accurate timing and the smart grids required for synchronization. Additionally, technologies such as solar panels for spacecrafts, when the solar radiation is enough to power the onboard instruments, or radioisotope thermoelectric generators, RTGs, for missions that cannot rely on the energy coming from the sun, have applications on Earth where RTGs have been used to power unmanned facilities. Recognizing both the hazardous nature of nuclear power sources as well as their necessity in particular cases, in 1978, the General Assembly endorsed recommendations for the Scientific and Technical Subcommittee of the Committee on the Peaceful Uses of Outer Space to formally consider the technical aspects of the safety measures relating to the use of nuclear power sources in outer space. These considerations resulted in adoption of the principles relevant to the use of nuclear power sources in outer space, which is also known as NPS principles, by the General Assembly in 1992. Under the principles, member states are required to inform Secretary General regarding safety assessments carried out prior to launch of nuclear-powered space objects for dissemination to other states and general public. Sustainable Development Goal 8 promotes sustained, inclusive, and sustainable economic growth, full and productive employment, and decent work for all. Roughly half of the world population still lives on an equivalent of $2 a day, and in too many places, having a job does not guarantee an escape from poverty. Slow and uneven progress in this area requires us to rethink and retool our economic and social policies aimed at eradicating poverty. A continued lack of decent work opportunities, insufficient investments, and underconsumption led to an erosion of basic social contract underlying democratic societies that all must share in progress. Sustainable economic growth will require societies to create the conditions that allow people to have quality jobs that stimulate the economy while not harming the environment. Space technologies support global economies and GDP growth, contributing to a range of sectors, particularly service delivery, utilities, banking and finance, agriculture and communications, lone workers monitoring, establishing safe and secure working environments. The space sector was worth more than 330 billion US dollars in 2017, with an average growth rate of above 6%. Several analyses suggest that the sector would grow to about 1 trillion US dollars by 2040, although other estimates predict a higher growth. The progress in open data policies have made possible that many startups could benefit from the space data for their applications, and the space technologies are contributing to establishing a safer and more secure working environment, enabling the monitoring of lone workers. The United Nations Office for Outer Space Affairs and the Committee on the Peaceful Uses of Outer Space have brought forward topics concerning the sustainability of outer space activities. Such activities on space debris and long-term sustainability of outer space to continue benefiting of space as the province of all humankind. On 11th May 2018, Kenya launched its first satellite. This satellite successfully deployed from the Japanese experiment module Kibo of the International Space Station made history as the first satellite launched with the support of the United Nations. This milestone was only made possible through an international collaboration between government, space agencies, academia, and the United Nations Office for Outer Space Affairs in its role as a capacity builder and facilitator. Through the Kibo Cube program, part of the access to space for all, developing countries have the opportunity to become spacefaring nations and consequently obtain another tool to add to their arsenal for the quest to achieve the SDGs. With special focus on the fight against poverty, following the Kenyan example, Mauritius was also selected to venture into satellite development through Kibo Cube. The first Mauritian satellite, the MIR-SAT-1, will be deployed with the following vision: to enhance access to space application tools for sustainable development in Mauritius through building capacity in basic satellite technology and creation of a collaborative network with renowned international space-related agencies, to allow Mauritius authorities and universities to get acquainted with the legal and regulatory considerations and responsibilities related to satellite projects, as well as understand the future deployment and operational requirements of such projects, to use the development of more sophisticated satellites in the future to support the needs of small island developing states and the African continent. By gaining access to space technologies, developing countries can achieve a rate of gross domestic growth of 7% or more for the least developed countries, along with the higher levels of economic productivity through diversification, technological upgrading, and innovation. Sustainable Development Goal 9 seeks to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. This SDG encompasses three important aspects of sustainable development, that is infrastructure, industrialization, and innovation. Infrastructure provides the basic physical systems and structures essential to the operation of a society or enterprise. Industrialization drives economic growth, creates job opportunities, and thereby reduces income poverty. Innovation advances the technological capabilities of industrial sectors and prompts the development of new skills. Inclusive and sustainable development industrial development is the primary source of income generation, allows for rapid and sustained increases in living standards for all people, and provides the technological solutions needed for environmentally sound industrialization. Space technologies play a key role in infrastructure mapping and monitoring, including maintenance of road infrastructure in rural environments, where the most reliable technology is satellite-based. Construction surveying through machine automation, smart mobility, example, reduce fuel consumption by smarter planning and monitoring of driving behavior. So global navigation satellite systems, GNSS in short, contribute to the construction of buildings and city infrastructure. The uses of GNSS for machine control, for example, automates construction activities by controlling the blades and buckets of construction equipment based on the information provided by 3D design. GNSS machine control increases the speed of grading by more than 50% relative to non-automated missions, and reduce the consumption of tarmac by 9% when paving, because the width and thickness is precisely as prescribed on the plans. Other applications include topographic surveys of construction sites and subsequent infrastructure monitoring. UNOSA has created the Access to Space for All initiative in its effort to facilitate key infrastructure development in space emerging and non-emerging space-faring nations. As part of the Access to Space for All initiative, the office has partnered with the China Manned Space Agency, in short known as CMSA, to offer opportunities for the experiments to onboard to China Space Station. Through this program, UNOSA intends to capitalize on the technological and innovation skills of the government of China to benefit member states of the United Nations, in particularly developing countries, thereby contributing to the SDGs through increasing access to space. The program provides scientists from all over the world with an equal opportunity to conduct their own experiments on board, and it is an innovative and future-focused program under UNOSA's Access to Space for All initiative to open up space exploration activities to all nations and to create a new paradigm in developing building capacities in space science, tech, and technology. Sustainable Development Goal 10 aims at reducing inequality within and among the countries. This SDG calls for reducing inequalities in income as well as those based on age, sex, disability, race, ethnicity, origin, religion, or economic or other status with a country. The goal also addresses inequalities among countries, including those related to representation, migration, and development assistance. The international community has made significant strides towards lifting people out of poverty. The most vulnerable nations, the least developed countries, the landlocked developing countries, and the small island developing states continue to make inroads into poverty reduction. However, inequalities still persist and large disparities remain in access to health and education, services, and other assets. Space technologies can contribute in various ways, for example, through connectivity in remote and isolated areas, remote participation in democratic process, reliable access to information, connectivity in remote and isolated areas, remote participation in democratic process, reliable access to the information. Space economy, the full range of activities and the use of resources that create value and benefit to human beings in course of exploring, researching, understanding, managing, and utilizing space is booming according to the estimate in 2017. The global space economy totaled $383.5 billion worldwide and employed well over 9 lakh people and is set to generate revenues of $1.1 trillion to more or more by 2040, according to some estimates and revenues. Some developing countries already have a large space sector, allowing them to tap into growth. Through space education and capacity development on space exploration and technology, more developing countries can take part in the booming sector and leverage its potential for inclusive economic growth. As competition in the sector increases, the price of launches and other space-related technology is falling. The fall in cost and other barriers to space particularly benefits the developing countries and allows new countries to share. Through membership in United Nations, specifically the Committee on the Peaceful Uses of Outer Space, all countries have representation and an equal voice influencing global decision-making in outer space. While remote and rural communities have traditionally struggled with access to education, space-based technologies such as satellite communication technologies are helping to rectify this inequality. Video conferencing and voice-over internet telephony focusing on youth, UNOSA supports the younger generation to gain knowledge and practical skills, offering them a chance to conduct experiments in microgravity, such as Zero Gravity Instrument Project, ZZIP, and Drop Tower Experiment Series, Drop TES, and in hypergravity, as well as enhancing their future prospects and spark their interest in some fields. To date, over 20,000 individuals have benefited from the training activities offered by the program on space application, the main implementation tool of access to space for all. Access to space for all is helping developing countries to become emerging nations and enter the space family through the facilitation of satellite deployments, following the example of Kenya, which deployed its first satellite with the first Mauritian satellite, MIRSAT-1, will enhance access to space application tools for suitable development in Mauritius through building capacity in basic satellite technology and creation of collaborative networks with renowned international space-related agencies. Moreover, Mauritius, apart from joining the group of space-faring nations, it is also become a member of Committee of the Peaceful Sustainable Development Goal 11 is focused on cities as more than half of the world population lives in them. Cities are hubs for ideas, conferences, commerce, culture, science, productivity, social development, and much more. They have enabled people to advance socially and economically. However, many challenges exist to maintaining cities in a way that continues to create jobs and prosperity without straining land and resources. So space technologies are utilized for urban planning to pinpoint structures and reference points for cadastral Space technologies are utilized for urban planning to pinpoint structures and reference points for cadastral and urban planning purposes, smart cities through the application of global navigation satellite systems, Earth observation and satellite communication systems, improvement of city services such as smart waste management systems, air quality monitoring, disaster management, infrastructure monitoring, search and rescue operations. So Earth observation and GNSS data support urban mapping and infrastructure monitoring to INOSA is also the Secretariat to the International Asteroid Warning Network, an association of institutions involved in detecting, tracking, and characterizing new Earth objects, which is in short known as NEO, and to the Space Mission Planning Advisory Group, SMPAG, which initiates that executes space mission response activities for NEO deflection. INOSA aims to raise awareness of NEO risk, enhance capacity of developing nations to protect and mitigate potential NEO impacts, and supportive, effective emergency response and disaster management along with such an event. Satellite data helps to support, plan, and monitor migration and mobility of people, either in case of human migration between different areas or mobility within urban centers, and assist disaster planning and emergency response. Sustainable Development Goal 12 aims at ensuring sustainable consumption and production patterns. SDG 12 is about promoting resources and energy efficiency, sustainable agriculture. SDG 12 is about promoting resource and energy efficiency, sustainable infrastructure, and providing access to basic services, green and decent jobs, and a better quality of life for all. Its implementation helps to achieve overall development, plans, reduce future economic, environment, and social costs, strengthen economic competitiveness, and reduce poverty, sustainable consumption and protection, are doing more and better with and increasing net welfare gains from economic addictive by reproducing degradation. So space technologies can assist with natural resource management, food and dangerous goods traceability, monitoring of endangered species, trafficking and products of human slavery, smart agriculture by combining Earth observation, satellite telecommunications, and global navigation satellite systems. "93% of the water on board the International Space Station is reclaimed. Currently, 40% of the oxygen in International Space Station is recycled, but NASA is researching technologies to increase the rate to 75%. Since the activation of the International Space Station urine processor assembly in 2008, more than 10 tons of drinkable water have been recycled from crew members' urine. If the amount of water had been supplied to Earth, it would be costing more than sir, developed the Teacher's Guide to Planet Experiments in Microgravity, which provides step-by-step instructions for educational experiments to discover the effects of gravity on planets in school laboratories. Sustainable Development Goal 13 urges to take action to combat climate change and its impacts. Climate change is now affecting every country on every continent. It is disrupting natural economies and affecting lives, costing people, communities, and countries dearly today and even more tomorrow. People are experiencing the significant impacts of climate change, which include changing weather patterns, rising sea levels, and more extreme weather events. Greenhouse gases emissions from human activities are driving climate change and are also continuing to rise. They are now at the highest levels in the history without action, and the world average it is disrupting natural economies and affecting lives, costing peoples, communities, and countries dearly today and even more tomorrow. People are experiencing the significant impacts of climate change, which include changing weather patterns, rising sea levels, and more extreme weather events. Greenhouse gas emissions from human activities are driving climate change and are continuing to rise. There are now at the highest levels in the history without action. The world's average surface temperature is promoted The UN, through support from the UK space agencies, has published the final report of a mapping exercise aimed at improving the understanding of the landscape of key intergovernmental coordination bodies using space technology to support climate action at the global level. Included in the mapping exercise are those bodies and in relation to the United Nations system as well work. Nations, entities, groups, and partnerships. Among the key conclusions, the exercise has been identified as well among the key conclusions. The exercise has identified well-coordinated and evolving climate observation, research, science, and policy developed by an ever-increasing stakeholder landscape. However, inconsistencies in the definition of climate action and services are rendering coordination more challenging. Following the COP21 agreement in Paris, the historical summit brought key global actors, including space agencies, together to combat climate change. The One Planet Summit facilitated discussing among leaders from the public and private sphere is on concrete actions against climate change. In one such initiative, the leaders of several space agencies proposed to set up a space climate observatory. Since most countries do not currently share climate data gathered by satellites, this agreement seeks to promote free and open data policies as well as satellite data products. The SCO could constitute a strategic contribution for the Space 2030 agenda and provides better opportunities to address SDGs, enabling worldwide cooperation and towards low emission and resilient societies. Sustainable Development Goal 14 pursues to conserve, sustainably use the oceans, seas, and marine resources for sustainable development. The world's oceans, their temperature, chemistry, currents, and life drive global systems that make the earth habitable for the humankind. Our rainwater, drinking water, weather, climate, coastlines, much of our food, and even the oxygen in the air we breathe, we all ultimately are all ultimately provided and regulated by the sea. They are particularly crucial for people living in coastal communities who represent 37% of the global population in 2010. Oceans provide livelihoods and tourism benefits as well as subsistence and income. They can also help regulate the global ecosystem by absorbing heat and carbon dioxide from the atmosphere and protecting coastal areas from flooding and erosion. In fact, coastal and marine resources contribute an estimated of $28 trillion to the global economy each year through ecosystem services. So space technologies support mapping and monitoring of natural and protected areas, fishing vessel tracking and navigation, monitoring of illegal, unregulated, and unreported fisheries, fishery product traceability, endangered exploitation of fishery resources, assessment and monitoring of marine and coastal resources, climate change monitoring, particularly water temperature, identification of algae blooms. Certain algae produces toxins that in large amounts can be harmful to marine life and potentially to humans. Algae forming these dense layers are described in harmful algal blooms, HABs, often referred to as red tides. So monitoring of harmful algal blooms is important for freshwater ecosystems to prevent the contamination of local drinking water source as well as in coastal regions to avoid shellfish poisoning and economic losses through impacts on local fisheries and tourism. So fish kills can result from associated toxins or from the immense depletion of oxygen caused by the increased algal cavity activity. General conditions that favor algal blooms are rising seawater temperatures and high nutrient loading from fertilizers. So monitoring algal blooms using space technologies is a vital tool to mitigate related impacts. UNOSA through UN Spider is offering information and advice on how to utilize space-related technologies for coastal and freshwater monitoring. UNOSA through the Access of Space for All initiative is also helping countries to have their own monitoring satellite. For example, Guatemala will launch its first satellite thanks to KiboQ, and program put together by UNOSA and Japanese Aerospace Exploration Agency. Sustainable Development Goal 15 seeks to protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, and halt and reverse land degradation and halt biodiversity loss. Preserving diverse forms of life on land requires targeted efforts to protect, restore, and promote conservation and sustainable use of terrestrial and other ecosystems. Goal 15 focuses on mainly forest, managing forest sustainability, restoring degraded lands and successfully combating desertification, reducing degraded natural habitats and ending biodiversity loss. So space technologies can be utilized for biogeophysical land surface monitoring, terrestrial biodiversity monitoring, monitoring of poaching, and identification of smuggling routes. So forests contain 3/4 of their plant biomass. Thanks to the satellites, it has been possible to obtain measurements on the forests in Australia in early January 2015, where 125 square kilometers were it is possible to derive Earth observation satellites, a series of bio and geophysical products on the status and evaluation of the land surface on a global scale and the set of biophysical variables describing the state, the dynamism, and the disturbances of terrestrial vegetation of mid and low spatial resolution. These products are used to monitor vegetation, the water cycle, and the energy budget. Satellites can also provide the information necessary to obtain physical variables of the canopy, like the leaf area index, the fraction of vegetation cover, and the fraction of radiation observed for photosynthesis, to respectively quantify the density, the extent, and the health of the vegetation. In addition, the dry matter productivity features the growth of standing biomass for specific ergonomic applications. Finally, maps of buried areas delineate the zones of the globe affected by intrusions. Satellites can also provide necessary to obtain physical variables of canopy, and also understanding animal movement is vital for biodiversity research, predicting conservation hotspots, identifying human-animal conflict zones, rebuilding and sustaining productive fisheries and ecosystems, and understanding the spread of pandemic diseases and invasive species. UNOSA, through the UN Spider platform, through the Knowledge Portal, provides information on good practices and standards on how to obtain satellite data, process it, and derive products for a wide range of users, including forest fires. Sustainable Development Goal 16 promotes peaceful and inclusive societies for sustainable development, provide access to the justice for all, and build effective, accountable, and inclusive institutions at all levels. Peace, justice, and effective, accountable, and inclusive institutions are at the core of sustainable development. Several regions have enjoyed increased and sustained levels of peace and security in recent decades, but many countries still face protracted armed conflict and violence, and for too many people struggle as a result of weak institutions and lack of access to justice and information and other fundamental freedoms. Space technologies are pivotal in conflict monitoring, enabling participation of remote and isolated communities in democratic process, enforcement of legislation, access to reliable information. So the Committee on the Peaceful Uses of Outer Space was set up in the General Assembly in 1959 to govern the exploration and use of space for the benefit of humanity, for all, for peace, security, and development. The committee was tasked with reviewing international cooperation in peaceful uses of outer space, studying space-related activities that could be undertaken by the United Nations, encouraging space research programs, and studying legal problems arising from the exploration of outer space. The committee has been instrumental in the creation of 5 treaties and 5 principles of outer space, which we have seen earlier. International cooperation in space exploration and the causes of space technology applications to meet global development goals are discussed in the committee every year. Owing to rapid advances in space technology and the agenda is constantly evolving, the committee therefore provides a unique platform at the global level to monitor and discuss these developments. Since 1992, 1962, the United Nations has maintained a register of objects launched into the outer space, originally established as a mechanism to aid the United Nations Committee on the Peaceful Uses of Outer Space in its discussions on the political, legal, technical issues concerning outer space. The evolution of international space law resulted in space object registration, becoming a means of identifying which states bear international responsibility and liability for the space objects. Following multi-year discussion among the states, the Convention on Register of Objects launched into outer space entered into the force in 1976. States and international intergovernmental organizations that agree to To date, over 89% of all satellites, probes, landers, crewed spacecraft, and space station flight elements launched into Earth orbit or beyond have been registered with the Secretary General. UNOSO is also the UN entity responsible for the planning and implementation of activities aimed at building member state capacity in space law and policy. So they have been working with established and emerging space-faring nations alike to support such awareness raising and adherence efforts since the office was established by the United Nations General Assembly in 1958. UNOSA works with stakeholders across the legal, policy, and capacity building aspects of international cooperation in the peaceful uses of outer space. In the context, UNOSA offers space for law capacity building and legal advisory services, targeted and tailored for regulatory authorities of new and emerging space-faring nations. These activities facilitate on request countries to draft national space law and/or policy that is in line with the international normative framework on space. Further, these services contribute to raising global adherence to and awareness of the existing international legal instruments on outer space for the benefit of established and emerging space-faring nations alike. So finally, the last Sustainable Development Goal, that is Partnerships for the Goal, seeks to strengthen the means of implementation and revitalize the global partnership for sustainable development. A successful sustainable development agenda requires partnerships between governments, the private sector, and the civil society. These inclusive partnerships built upon principles and values, a shared vision, and shared goals that place people and the planet at the center are needed at the global, regional, national, and local levels. Space technologies enable international cooperation initiatives, exchange of data and information, open source databases, sharing of infrastructure, and exchange of technical know-how. With the partnership with public sector, the United Nations Office for Outer Space Affairs strive to provide opportunities under the access to space for all initiative. This initiative aims at assisting countries to access outer space, starting from developing experiments in microgravity conditions and understanding the implications of these conditions with projects as Zero Gravity Instrument Project, which provided clinostats that can stimulate the effect of microgravity along one axis by rotation. The office offers access thanks to the partnerships to different opportunities, such as KiboQ, a partnership with the Japanese Aerospace Exploration Agency, JAXA, to deploy CubeSats from the International Space Station. The Chinese Space Station, a partnership with the Chinese Space Manned Agency, which offers hosting payloads in the upcoming Chinese Space Station. Drop Test, a partnership with the Center of Applied Space Technology and Microgravity, in short known as ZAM, or a partnership with the European Space Agency on the use of large diameter centrifuges. The successful collaboration model has provided and continues to provide capacity building opportunities at educational institutions for the design, construction, and deployment of microgravity experiments, resulting in high-skilled individuals and know-how which truly demonstrate the benefits of space to society. Innovation derived from space exploration endeavors is also a key driver of socio-economic development and technical progress on Earth for the benefit of all humankind, providing growth, jobs, and long-term returns. The office has played a crucial role in channeling appropriate opportunities generally or generously donated by countries having space capabilities to institutions in developing countries that would otherwise have little or no prospect of carrying out space-related scientific research. At the same time, with partnership with the private sector, the Secretary General, in his report entitled Enhancement Cooperation between the United Nations and all relevant partners, in particular private sector, with Resolution 72 by 310 of 10th August 2017, stresses to unlock the full potential of partnerships, in particular business partnerships, a number of priorities to strengthen accountability and transparency, enhance coherence and capability, and advance system-wide collaboration are recommended. The office has been requested to pursue greater engagement and industry and the private sector to further their support and contribution to the overall work of the office pursuant to the General Assembly Resolution 72 by 79 as an endorsed by the Committee on the Peaceful Uses of Outer Space at its 16th session in 2017. So the office has built a portfolio for the Human Space Technology Initiative based on opportunities offered by space agencies and research institutions in member states. This portfolio is being enlarged thanks to the contributions of the industry and the private sector, such as first space mission planned to be devoted to the Sustainable Development Goals with Sierra Nevada Corporation, whose call for interest gathered 150 expressions of interest from 75 different countries, showing the great interest and demand for space-related capacity building in the very specific field of microgravity experiments. Or the partnership with Airbus to offer a slot to conduct experiment on the So this is how the space technologies are contributing to the Sustainable Development Agenda 2030. So the Center for Space Science and Technology Education in Asia and the Pacific, in short known as CSSTEAP, on 1st November 1995, the Center for Space Science and Technology Education in Asia and the Pacific region was inaugurated at New Delhi, India. As we have seen how these space technologies have been contributing to the sustainable development goals, since the first satellite to provide measurements of its atmospheric temperatures was launched in 1969, space assets have been increasingly key for climate monitoring and today for climate action. Earth observation data has been central to the formulation of the scientific consensus on the nature and magnitude of the climate change. More than half of the essential climate variables characterizing Earth's climate can be monitored from space and help inform mitigation strategies. Meanwhile, space-enabled capabilities such as satellite communications and geospatial positioning are helping adapt and become resilient to the climate change. Applications of space research and cutting-edge technologies developed for space exploration are also diffusing into society and industries and offer new means for action. As more and more actors get involved and projects get started to provide space-enabled climate services, there is a growing need for awareness, raising, information sharing, and coordination to realize the full potential of these capabilities. Space for Climate Action is an initiative of the United Nations Office for Outer Space Affairs, UNOSA, to promote the use of space technologies and applications to support climate action, which is also Sustainable Development Goal 13, which are just to take action to combat climate change and its impact. Climate change is affecting every country on every continent. It is disrupting national economies and affecting lives. Weather patterns are changing, sea levels are rising, and weather events are becoming more extreme. Greenhouse gas emissions from the human activities are driving climate change and are continuing to rise. They are now at the highest levels in the history. Without action, the world average surface temperature is projected to rise over 21st century and is likely to surpass 3 degrees Celsius this century. As part of its efforts to support climate change, climate action, the United Nations Office for Outer Space Affairs is maintaining this website dedicated to informing on the space-based capabilities for climate action and orientation towards adequate actions and resources where we can get all the information. The Space for Climate Action website offers capacity building resources targeted to everyone: citizens, organizations, companies, universities, policymakers, or experts to inform your own strategy development or research and gain a more competitive understanding of the current efforts. So with this, we conclude this topic, space technologies for sustainable development goals and space technologies for climate action. So we'll move on to our other commemorations and conclude. I think the other speaker is not able to connect due to technical problems. We'll see if we can cover that. So today is also commemorated as International Chess Day or World Chess Day. As you know, this game, chess, has originated in our own country, India, and it is quite popular across the world. The United Nations recognizes that sports, the arts, physical activity, have the power to change perceptions, prejudices, and behaviors, as well as to inspire people, break down racial and political barriers, combat discrimination, and diffuse conflict, and therefore contribute in promoting education and sustainable development, peace, cooperation, solidarity, social inclusion, and health at the local, regional, and international levels. Chess is one of the most ancient intellectual and cultural games, with a combination of sports, scientific thinking, and elements of art. As an affordable and inclusive activity, it can be exercised anywhere and played by all, across the barriers of language, age, gender, physical ability, or social status. Chess is a global game which promotes fairness, inclusion, and mutual respect. And noting in this regard, it can contribute to an atmosphere of tolerance and understanding among people and nations. So chess is a two-player strategy board game where the aim is to move different types of playing piece, each with a prescribed set of possible moves around a checkered square board, trying to capture the opponent's king piece. Today, there are over 2,000 identifiable variants of the game. One theory is that early games similar to the chess called Chaturanga originated in the North Indian subcontinent during the Gupta period in between 319 to 543 CE and spread along the Silk Roads west to Persia. While the modern chess is believed to have been derived from Chaturanga means, that is 4 divisions, referring either to the divisions of the playing pieces into infantry, cavalry, elephantry, and chariotry, pieces which in the modern game became the pawn, knight, bishop, and rook, or the fact that the game was played by 4 players, Chaturang and later Shatranj was the name given to the game when it arrived in Persia around 600 CE. The earliest reference to the game comes from a Persian manuscript of around 600 CE, which describes an ambassador from the Indian subcontinent visiting King Khosrow and presenting him with the game as a gift. From there, it spread along the Silk to other regions, including Arabia Peninsula and Zantia. So in 900 CE, Abbasid chess masters Al-Suli and Al-Laj composed works on the techniques and strategy of the game, and by 1000 CE, chess was popular across Europe and in Russia, where it was introduced from the Eurasian steppe. The Alfonso manuscripts, also known as the Libro de los Juegos, Book of Games, a medieval collection of text on 3 different types of popular games from the 13th century CE, described the game of chess as very similar to the Persian Shatranj in rules and gameplay. So on December 12th, 2019, the General Assembly proclaimed 20th July as the World Chess Day to mark the date of the establishment of the International Chess Federation, in short known as FIDE, in Paris in 1924. Under initiative of the FIDE, July 20 has been observed as the International Chess Day by chess players around the world since 1966. So the designation of the World Chess Day of the United Nations will not only recognize the important role of the FIDE in supporting international cooperation for chess activity and aiming to improve friendly harmony among all peoples of the world, but also to provide an important platform to foster dialogue, solidarity, and culture of peace. Traditional games include chess, and its many variants constitute important elements of the cultures of different people living along the Silk Roads. The interactions and encounters have been taking place for thousands of years along the Silk Roads, provided considerable opportunities not only for the spread of traditional games throughout the different regions, but also for the enrichment at different levels. Chess, being a mind game, encourages deep logical thinking, which enhances responsible action, thus promoting the playing of chess. And linking this with issues of sex and sexuality could be a creative and strategic way of taking up the HIV/AIDS challenge. About 70% of the adult population, US, UK, Germany, Russia, India, has played chess at some point in their lives. 605 million adults play chess regularly. Mathematically, there are more possible games of chess than there are atoms in the observable universe. It is possible to checkmate an opponent in chess in just 2 moves. The oldest living grandmaster is Yuri Everbeck, who celebrated his 100th birthday in May 2022. As we celebrate International Chess Day, a day that was born from an idea of United Nations, educational, scientific, and cultural organizations, UNESCO had chess popularity can also be attributed to the fact that it was associated with wealth, knowledge, and power. It evolved to resemble the current version of chess in England by the 15th century. So the game as we know it as soon established by an Englishman adopting the black and white squares as we know so well. FIDE rankings put Russia at the top, with the US coming in the 2nd place and China in the 3rd, which are strong in playing chess and chess games. So if you want to if you love watching movies, you can select from Searching for Bobby Fischer, which was released in 1993, Queen of Cutway in 2016, or the recent Netflix series, The Queen Gambit, to begin with, to have a chess-themed movie tonight. A match in 1959 became so heated, one player attacked another with an ice axe. Thus, chess is banned in Russian Antarctic stations. So, a 2012 survey found that about 605 million adults around the world play chess on a regular basis, which makes up a large community. The wizard chess pieces in Harry Potter and the Sacred Stones were based on the medieval set, which was found to be the Islay of Lewis in northern Scotland and is from 12th century. A new frontier in computing came when a computer beat chess world champion Garry Kasparov in 1996. Now they do it all the time. Hungarian chess player Janos Fletch set a world record in Budapest in 1960, playing 52 opponents simultaneously while blindfolded and winning 31 of these games. So this game, or at least some versions of it, has been played since ancient times. It combines sport, strategy, scientific thinking, and elements of art into one of the most intellectual pastimes of our world. And the game of strategy is great for our brain cells. Psychologists recommend playing chess to improve memory function, and doctors prescribe it to fight Alzheimer's. The effects of chess on young children, it is proven to increase grades, promote social behaviors, among other positive effects, have led to chess being introduced in school curriculums across various countries. So this is a perfect time. If you are not playing chess, you can start playing, or you can start learning from today. So that's all about chess. Due to time constraints, we are limiting. Maybe in coming days, like last year, we also commemorated this day, and we also had sessions on how to play chess and all these things. Maybe in coming days, in the next week, we'll dedicate one day, and where we will try to explore what are different pawns and elements of chess and how to play chess. And if possible, we will try to learn chess. Those who do not know chess, will inform you in advance. And there is also special occasion today that International Chess Federation is celebrating 99th birthday this year, today. So many of you across the world will celebrate International Chess Day with various activities and happenings all about our beloved game. On this day, we want to reinforce the tradition started in previous years and ask all of us, especially the chess community, to teach someone how to play chess. So the more, the merrier, be it your neighbor, niece, colleague, or grandfather or grandchildren. Let's make chess family grow. And let's make our celebrations really big and prove that chess is the most played game in the world. As we know, as we have seen, that it was United Nations choose exactly July 20 to celebrate chess, to mark the date of the International Chess Federation establishment in 1924. So it is also birthday of International Chess Federation, and today, this year being 2023, next year 2024, it will be 100 years. So this year, since 1924 to 2023, on this day, FIDE, that is International Chess Federation, that is in short known as FIDE, that stands for Federation International des Chess, is celebrating 99th birthday this day. And this is a governing body for the game of chess internationally. It organizes major chess events which form the World Championship Cycle, Chess Olympiads, Rapid and Blitz Championships, tournaments for peoples with disabilities, veterans, and children, as well as various exhibition and online events. It awards international chess titles like the coveted Grand Master and calculates rating. FIDE creates and implements the rules of chess and standards for tournaments. It is actively involved in social projects and promotion of chess on the grassroots levels. FIDE is recognized by International Olympic Committee and includes as many as 199 national chess federations. So, in 1927, FIDE organized the first Chess Olympiad and first Women's World Championship in London. In 1948, FIDE started overseeing the World Chess Championship. Today, both absolute and women's chess crowns belong to the players from China, Ding Liren and Jui Wenjun. In 1950, FIDE awarded its first Grandmaster title to 27 players. Today, FIDE titles also include International Master, Women's Grandmaster, Women's International Master, and lower level ones like FIDE Master or FIDE Candidates Master. The first official FIDE rating list came out in 1971. The universal rating system, named after its creator, Arpadillo, measures a player's skill level and tracks their progress over time. New rating lists are out at the beginning of every month, and professionals and amateurs alike are eager to check their numbers next to their surname. In 1999, FIDE was recognized by the Olympic Committee, a major milestone in the organization history. The motto of FIDE is Gens Unus Sumus, which translates from Latin as "We are one family." This motto is a reflection of organization's vision of chess as a sport that unites people all over the world. Finally, family means care, and in recent years, FIDE social projects have become an essential part of the organization operations. Infinite Chess Project introduces the game to children with autism spectrum disorder. Chess for Freedom program brings chess behind the bars of prisons. Chess for Protection helps refugees find their way with the help of the game. FIDE financially supports its veterans in needs and holds competitions for the people with disabilities. The first Chess Olympiad for people with disabilities took place in January, February 2023 in Belgrade this year. Chess has found its place in ever-changing world of modern technology. Today, FIDE organizes online and hybrid events and implements new technological solutions. In 2023, chess became part of the Olympic Sports Series. Next year, FIDE will celebrate its 100th year birthday. The International Chess Federation has come a long way since its first steps a century ago. Today, it is based in Switzerland alongside with other major sports governing bodies. It encompasses 199 national chess federations, which makes FIDE one of the largest sports federations in the world. Throughout its history, FIDE has been instrumental in shaping the world of chess, and we never stop aiming for new heights, serving the game and chess community. Today is also commemorated as International Moon Day. So on July 20, the Moon Society, in partnership of Moon-based Laprosec Foundation and the Lunar Homestead, the Moon Society organizes International Moon Day every year. So today is also commemorated as Space Exploration Day. It is also known as National Moon Day. President Ronald Reagan created this holiday or commemoration to commemorate the first crewed mission to the moon and moon landing, which took place on July 20, 1969. 80 years after President John F. Kennedy set a goal for America to land on the moon before the end of the decade, the Apollo 11 mission succeeded. The day also seeks to inspire and encourage young people to pursue careers in space sciences and space exploration. On July 16, 1969, NASA's Apollo 11 mission launched from Kennedy Space Center in Florida, USA. There were 3 astronauts aboard the rocket ship: Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins. At 1:46 p.m. on July 20, the lunar module, nicknamed the Eagle, carrying only Aldrin and Armstrong, separated from the command module where Collins was. At exactly 10:56 p.m. on that day, Armstrong became the first human to set foot on the moon as he descended from the ladder, making the famous quote that it is now known all over the world: the one small step for man, one giant leap for the mankind. In reality, Armstrong claimed that he actually said, "That's one small step for a man, one giant leap for a mankind." His words were garbled by the microphone he was using. So 19 minutes later, Aldrin has also planted his boots on the moon's surface. For the next several hours, both men planted the US flag, took photographs of the surroundings, even communicated with the President Richard Nixon. That night, Aldrin and Armstrong slept in the lunar module on the moon's surface. By 1:45 p.m. on July 21st, the Eagle began its ascension back to the other module, successfully rejoining it about 4 hours later. Finally, on July 22nd at 12:56 a.m., the journey back to Earth commenced, and the Apollo 11 made a safe splash into the Pacific Ocean on July 24 at 12:50 p.m. Space is nearly perfect vacuum, and there is almost nothing in the space between the stars and planets to scatter light. That's why our eyes only see black. That's why we say space is black. Time in space is complicated, but most sources say that a day on the moon lasts about 29.5 Earth days. It is roughly around 30 days. Neil Aldrin Armstrong was born on August 5, 1930, in Ohio. Sponsored by the United States Navy, he studied aeronautical engineering at Purdue University, Indiana, and graduated in 1955. He joined the NASA Astronaut Corps in 1962 and made his first spacecraft as the command pilot of Gemini 8 in 1966. Among many others, Armstrong was awarded the Presidential Medal of Freedom by President Richard Nixon. And finally, Armstrong died at the age of 82 after an unsuccessful coronary bypass surgery. So this day celebrates the significant moment in the history when America was the first country to land humans on the moon. And it's a glorious example of the American ingenuity and advancement. Today also shines the spotlight on the field that is rarely spoken of. This day allows us to celebrate the work of thousands of nameless, behind-the-scenes people who work tirelessly to make space missions a success. They all deserve to be recognized and honored for their commitment, brilliance, and bravery. This day not only recognizes and celebrates the past work of astronauts, scientists, engineers, etc., but it also paves way for the future interest in the field. With all the awareness activities related to space exploration, the day will inspire more young people to pursue space-centered careers. Today, we have also similar commemoration. Like today is Women's Union Establishment Day in Laos, which is one of the most important official days in the country and carries more significance in the context of international movement for equal rights for women, especially gender equality. So it is one of the longest struggles that eventually granted women their rights and promoted more favorable policies for women. So this is a symbol of the plight of women and how this can be changed. Although Laos is not a wealthy country, it has managed to adopt some progressive policies early on in the 20th century. The highlights of the significance of the Women's Union Establishment Day, which was celebrated in the country for at least several decades. So this celebrates the founding of Laos Women Union, which is today one of the strongest institutions in the country. It was founded on July 20, 1955. Throughout the following decades, the Laos Women's Union played a key role in promoting the inclusion of women in business, politics, and other areas. Other than initiatives aimed at raising awareness regarding the issue, the union helped pave the way for many public policies that are more favorable to women. From attending women's rights to equal rights with men, to access to education and social welfare, the Laos Women's Union served as a main guardian of the rights and the status of women in the country. The Laos Women's Union held its first National Congress in 1984, which is a significant moment in the union's history as it helped unify its efforts and sought devising the principal plans for the union's future projects. The union has been holding a National Congress every 5 to 7 years. Currently, Laos Women's Union has a membership of over 1 million, making it one of the strongest social and political organizations in the country. The Lao language is the official language of Laos. It is traditionally spoken language in many parts of the country. The situation in Laos is still challenging concerning women with a gender inequality index value of 0.4. The main human rights issues in Laos, especially during last few years, include forced detention and political prisoners. And Laos is known as the land of million elephants because of the country's massive pastures where elephants used to dwell. Coffee is the country's biggest export as Laos offers the best conditions for growing coffee beans and is one of the world's top producer of the coffee beans. Laos is one of the most culturally and ethically diverse countries in the world, with over 60 ethnic groups inhabiting the country. And Laos is the home to the oldest human fossil found in the Southeast Asia, making it home to one of the earliest societies in the history. Laos is only landlocked country in the Southeast Asia, which is rather odd in this region. The importance of that the Laos Women Union signifies in the country is indicative of the status of women in society. Despite the various challenges still facing women, the Lao Women's Union is an important advocate of women's welfare. As one of the strongest political entities in the country, the Lao Women's Union played a significant role in building of the country's modern political system. The annual celebration commemorating its founding is a testament to its significance. So this day is also commemorated as World Jump Day, and there's no dearth of scientifically sound or otherwise approaches to tackling global warming. So the day aims to shift the orbit of Earth to extend daylight hours to create a more standardized climate throughout the world. So this day is observed as a way of taking a light-hearted and stern look at very serious issue of global warming and climate change. Although it is possible to change the orbit of Earth, jumping is a lot of fun. So it was started by German artist Torsten Lochmann, who popularized the idea through his website, and the day was first observed on July 20, 2006, after the site gathered almost 6 crore registered jumpers. So Launchman presented jumping as an art installation to raise awareness about global warming. Today, the day is mostly celebrated in jest, since we all know that our climate weight of the Earth is so minimal that it will have no impact on the planet's orbit whatsoever. The day is considered to be unscientific and was widely discredited. Whatever the reason may be, jumping is fun and good form of exercise. But I think this is a similar phenomenon of this Thomas Dam built by China, where it is the largest dam on the planet, which has slowed down the Earth rotation. So maybe I think this is similar concept also, because of the water's concentration of water, the huge weight of accumulation of water on the planet that has slowed down the Earth rotation. So maybe if all at once, if any earthquake comes, just imagine what if the Thomas Dam breaks, or if any earthquake occurs in the dam region, maybe the entire planet is at high risk. And the entire China and the surrounding nations will be flooded. Maybe for every dam, there are a lot of risks concerned, but especially with these huge dams, there is a lot of, and especially China has the credit of dams which were, built, and they were great disasters in various dams because of the huge projects they are building. Anyway, let's hope for the best, that nothing happens. So this day is celebrated exactly at 11:39:13 GMT. At this time, millions of people from the Western Hemisphere jump simultaneously, and it is believed that the coordinating jumping will force the planet to move out from its original orbit and into a new one. And this would stop global warming, but not all of it is a joke. Some scientists believe that if 600 million people, now it's almost 800 million people jump at the same moment, the Earth will move a bit from its orbit, which increases the distance between Sun and Earth, thereby reducing the risks of global warming. But again, this is one of the disasters, because thanks to the human beings we have set a series of disasters on the planet. And without knowing, without properly understanding, we are continuing to create so many disasters. And this can also lead to one more disaster, because we do not understand, even a slight millimeter of this distance, how it can impact our planet or the solar system. But anyway, so it is based on the theory that changes in Earth mass will make a difference in the Earth's orbit. Needless to say, it is unproven that having millions of people jump at the same time would make a difference in Earth's orbit. But anyway, jumping jacks are a great way to get some exercise and quickly. Doing up to 30 jumping jacks a day can significantly improve your physical health. So especially in the West, it is summer. So cool off in summer by jumping or dividing at your local pool. It is a great way to enjoy double health benefits of jumping and swimming. So as it is an awareness about global warming, it's a great day to take pledge to do your bit. Switch to public transport, biodegradable packing, say no to single-use plastic, or simply have shorter showers for a more sustainable future and be a responsible citizen. By 2040, the Arctic might have completely ice-free summer as the Arctic ice is melting swiftly and there may be no these poles with glaciers. Global warming is responsible for the extinction of 1 million species. And thanks to the human activities, they are the greatest disaster for the planet. The carbon dioxide levels in the 20th century have been in the highest in 650,000 years. And by the year 2100, the average temperature will rise by 42 Fahrenheit. And the earth is heating up like anything. And it will also endanger human life between 2000 and 2100. There might be up to 150,000 heat-related deaths. Even recently, also day before yesterday, in US, we have seen US and the counterparts, Western countries. We have seen one side there is huge temperatures, and the other side there are, devastating floods. So these are the disasters we human beings are creating through our human activities. So pseudoscientific reasoning aside, this day brings out an inner child in all of us. Jumping jacks, jumping ropes, or even skipping ropes or jumping on a trampoline can be a great stress buster. And it is also a fun way to get kids and adults to care about the planet and do their bit. And jumping is a simple way to keep blood flowing and get some movement on a busy day. This also reminds us taking care of our health and can be fun and easy. So finally, before concluding, as we were talking about moon, so recently, Indian Space Research Organization, Department of Space, Government of India has launched Chandrayaan-3 is a follow-on mission to the Chandrayaan-2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. It has been launched by LVM-3 from SDSC, Shar Sriharikota, Andhra Pradesh, India. The propulsion module carried the lander and rover configuration till 100-kilometer lunar orbit, and the propulsion module has spectropolarimetry of habitable planet Earth shape, payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. So Chandra's surface thermophysical experiment chassis to measure the thermal conductivity and temperature, instrument for lunar seismic activity, ILSA for measuring the seismic surrounding the landing site, and Langmuir probe LP to estimate the plasma density and its variations. A passive laser retroreflector array from NASA is accommodated for lunar laser ranging studies are the lander payloads. Rover payloads include alpha particle X-ray spectrometer, APXS, and laser-induced breakdown spectroscope, LIBS, for deriving elemental composition in the vicinity of the landing site. Chandrayaan-3 consists of an indigenous lander module, LM, and propulsion module PM and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of the propulsion module is to carry the lander module from launch vehicle injection till final lunar 100-kilometer circular polar orbit and separate the lander module from propulsion module. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post-separation of lander module. The launcher identified for Chandrayaan is GSLV Mk3, which will place the integrated module into elliptic parking orbit EPO of size 170 into 36,500 kilometers, which was successfully placed on 14th July. So the mission objectives of the Chandrayaan-3 are to demonstrate safe and soft landing of lunar surface, to demonstrate roving on the moon, and to conduct in situ scientific experiments. To achieve the mission objectives, several advanced technologies were present in the lander, such as altimeters, laser and RF-based altimeters, velocimeters, laser Doppler velocimeter and lander horizontal velocity camera, inertial measurement laser, gyro-based inertial referencing and accelerometer package, propulsion system, 800N throttle level, liquid engines, 58N altitude thrusters and throttle level engine control electronics, navigation, guidance and control, NGC, power descent trajectory design and associate software elements, hazard detection and avoidance, lander hazard detection and avoidance camera and processing algorithm, landing leg mechanism. And to demonstrate the above said advanced technologies in Earth conditions, several lander special tests have been planned and carried out successfully. Integrated cold test for the demonstration of integrated sensors and navigation performance test during helicopter as a test platform. Integrated hot test for the demonstration of closed loop performance test with sensors, actuators, and NGC using tower crane as test platform. Lander leg mechanism performance test on a lunar stimulant test-based test bed simulating different touchdown conditions. The overall specifications for Chandrayaan are mission life for lander and rover is 1 lunar day, that is 14 Earth days. Landing site is 4 kilometer into 2.4 kilometers, 63.367621 south and 32.348126 east. This is latitude and longitudinal. Science payloads on lander, radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, in short known as RAMBA. Chandra's surface thermophysical experiment, in short known as CHASTI. Instrument of lunar seismic activity, in short known as ILSA. Laser retroreflect array, LRA, rover. Alpha particle X-ray spectrometer, APXS. Laser induced breakdown spectroscope. LIBS propulsion module, spectropolarimetry of habitable planet Earth, in short known as SHAPE. So 2-module configuration with propulsion module carries lander from launch injection to lunar orbit, and lander module rover is accommodated inside the lander. And the total mass weight propulsion module is 2,148 kgs. Lander module is about 1,752 kg, including rover of 26 kgs. A total mass is 3,900 kilograms. And the power generation propulsion module is of 758 watts, lander module 738 watts, WS with bias, rover 50 watts. Communication, propulsion module communicates with IDSN, lander module communicates with IDSN, and rover Chandrayaan-2 orbiter is also planned for contingency link. Rover communicates only with the lander. Lander sensors is equipped with laser inertial referencing and accelerometer package, in short known as LIRAP, Ka band altimeter, in short known as KARA, lander position detection camera, LPDC, LHDAC, lander hazard detection and avoidance camera, laser altimeter, LASA, laser Doppler velocimeter, LDV, lander horizontal velocity camera, LHVC, microstar sensor, inclinometer and touchdown sensors. Lander actuators, reaction wheels, 4 numbers, the 10 MNs and 0.1 Nm. Lander propulsion system is bi-propellant propulsion system, MMH plus M0N3, 4 numbers of 800N throttleable engines and 8 numbers of 58N throttleable engine control electronics. Lander mechanisms, lander leg, rover ramp, primary and secondary, rover, ILSA, Ramba and chase payloads, umbilical connector protection mechanism, expand antenna. Lander touchdown specifications, vertical velocity is less than or equal to 2 meters per second. Horizontal velocity is less than or equal to 0.5 minutes per second, and slope is less than or equal to 120. So the objectives of scientific payloads planned Chandrayaan-3 lander module and rover are the following. Payloads has the following objectives, like radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, in short known as Ramba, with the Langmuir probe LP to measure the near surface plasma ions and electrons density and its changes with time. And the other payload, Chastity, to carry out the measurements of thermal properties of lunar surface near the polar region. An instrument of lunar seismic activity to measure seismic activity around the landing site and delineating the structure of lunar crust and mantle. Laser retroflector array. It is a passive experiment to understand the dynamics of moon system. And rover payloads and its objectives, laser-induced breakdown spectroscope, which is a qualitative and quantitative element analysis to derive the chemical composition and infer mineralogical composition to further understanding of lunar surface. Alpha particle X-ray spectrometer to determine the elemental composition, Mg, Ai, Si, K, Ca, Pi, Fe. These are of lunar soil and rocks around the lunar landing site. And the propulsion module payload, spectropolarimetry of habitable planet Earth, in short known as SHAPE, future discoveries of smaller planets in reflected light would allow us to probe into variety of exoplanets which would qualify for habitability or for presence of life. So finally, we will just watch a video. And yeah, coming to latest updates on Chandrayaan and its timeline. So the launch was scheduled for July 14 at 14:35 hours IST from the second launch pad, SDSC Shar Sriharikota on July 6, 2023. And July 7, 2023, vehicle electrical test completed. Citizens are invited to witness the launch from the launch view gallery at Sriharikota by registering. And on July 12, 2023, the launch rehearsal, stimulating the entire launch preparation and process lasting 24 hours, has been concluded. On July 14, 2023, LVM-3M4 vehicle successfully launched Chandrayaan into the orbit. Chandrayaan-3 in its precise orbit has begun its journey to the moon. Health of the spacecraft is normal. On July 15th, the first orbit raising maneuver, Earthbound Firing 1, is successfully performed at ISRO Bengaluru. Spacecraft is now in 41,762 kilometers into 173 kilometer orbit. July 17th, the second orbit raising maneuver performed. The spacecraft is now in 41,603 kilometers into 226 kilometer orbit. So let's watch a short video.
This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, Moon, the only natural satellite of the Earth, has acquired added importance due to the belief that Moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, Moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launch by India's most capable rocket LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the Moon's surface. And the 4th instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The 2 instruments on the rover help us study the composition of the Moon's surface using X-rays and laser respectively. While the lander and rover will be in direct contact with each other, the propulsion module circling the Moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it, and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
Thank you everyone for joining us. In the commemorations of International Moon Day and also International Space Exploration Day, and being participant in the international seminar. After the closure of this seminar, in next 5 to 10 minutes, the Google form, which is registration, feedback and e-certificate form will be opened. We request everyone, whoever is attending, to quickly fill up the overall feedback form in Zoom. And later on, you can fill up the Google form within 24 hours. Certificates will be updated on the website from where you can download it in a couple of days. Before leaving the platform, quickly fill up the feedback form. So it will be open for another 4 to 5 minutes. We thank everyone for joining us and making this international seminar successful. And we express our sincere gratitude to all the participants and presenters. So see you all tomorrow for the international webinar series with the same joining link at 6 p.m. Take care. Good night.